All right, in this video, we are going to talk about the basics of inheritance in Java. So, inheritance is a mechanism by which one Java class can inherit the fields and methods of another Java class. Okay, so um, just as an example, maybe you have some code that somebody else has written, and it does, everything that it works pretty well, but you kind of say to yourself, hey, maybe there's this one extra thing that it needs, and I can add on to it. And so in Java, you can do that. You can just use that other person's code as the basis for your new code, and through inheritance, you won't have to write the other code again. You can just use the code that the other person provides and just add whatever it is that you want to add onto it. Okay. Okay, so first, before we get into the details, we need to talk about some terminology. The class that is used as the basis for an inheritance is called the parent class or superclass or base class. I will pretty much stick with parent class just because I think it's easier to understand. Parent and child. But you will see these other terms used quite frequently: superclass or base class. Okay, so the class that inherits from the parent class is called the child class, or if you're using superclass, then the child class is called a subclass, or you might hear base class and derived class. All right. So again, I'll pretty much stick with parent and child, but you will see these others in books and discussions about inheritance. All right, so as a first example, let's say that we are writing a program for some company, transportation company, okay, and we want to keep track of all their vehicles, right? So they can know to perform maintenance and order parts and those types of things, okay. Let's suppose the company has a bunch of different types of vehicles: trucks, cars, ships, submarines, airplanes, helicopters, etc. Okay, so lots of different types of vehicles. There are some things though that would probably be common to every type of vehicle that you might have, that the company might have. Every vehicle probably has some kind of ID number, right? So they can keep track of it. And all of the vehicles probably have some kind of manufacturer. So, and I'm sure there's many other things, but those two are good enough for our example here. All right. So all of the vehicles have an ID number and a manufacturer. All right. So one approach you might take is to cram all of these everything into one giant class to try and accommodate all of these different types of vehicles. All right. So for trucks and cars, you would want to keep track of how many wheels they have and what kind of tires are on those wheels or whatever, but you wouldn't really need that for a ship or submarine or a helicopter because they generally don't have wheels. Okay, just like airplanes have wings, but submarine ships and cars don't generally have wings in there. So um, try to cram all of the information into one single vehicle class is really probably not the best approach to it. So what we are going to do instead, and what you can do using inheritance, is to start off by making a general vehicle class, and that vehicle class will contain fields and methods that basically every vehicle would have. Okay, so for instance, this general vehicle class would have a field for the vehicle ID number and a field for the manufacturer, because every one of their vehicles is going to have that. But it wouldn't necessarily have all of the things that are needed for the different types of other vehicles. All right, so let's take a look at vehicle.java and take a look at how that is set up. So here is the vehicle class. So in this vehicle class, I have two fields. I have the vehicle ID number field, and I have the manufacturer field. So those variables will keep track of the vehicle ID number and the manufacturer. Here in this example, I did not put a constructor because that's going to take some additional add some additional complexities that I don't want to discuss in this first video. We will talk about that in the next video. All right, and so then I've got a toString method, and the toString method just prints out the vehicle ID number and the manufacturer. All right, and then I just have some get and set methods here. One for a pair for vehicle ID number and another for the manufacturer. Okay, and so notice I don't try to cram every single thing into the vehicle class. This stuff that's in here is common to every single vehicle that the company has. All right. So then what I'm going to do is set up different child classes based on that vehicle class. Okay. And this is just going over what I mentioned before about, the company has a lot of different types of vehicles. Each type of vehicle is going to have their own considerations, wings or wheels or whatever it is. And so what we're going to do, instead of trying to cram every field and method possible into that single vehicle class, we are going to create child classes of the vehicle class. Okay. So typically when you're doing this, the child classes are more specialized versions of the parent class. Okay. So, and that's typical of inheritance in Java. All right. So the next class that we are going to create, we're going to create a child class for land vehicles, right? So a land vehicle is a vehicle. So normally child classes satisfy that is a relationship, right? A land vehicle is a vehicle. But if you notice, it's not the other way around. Not every vehicle is a land vehicle. That's not true, okay? Because you have a submarine, which doesn't go on land, right? So typically the child classes are more specialized and they satisfy that is a relationship. Okay, so how do I accomplish inheritance in Java? You do it through the extends keyword. When you want to make a child class, what you would do is in the class header, then you would put the extends keyword, right? So public class, land vehicle, that's the child class that I'm going to make. So land vehicle would be the child class. And then whatever class is over here is going to be the parent class, right? So that extends keyword automatically makes land vehicle a child class of vehicle, and land vehicle will automatically inherit all of the fields and methods of the vehicle class. All right, you don't have to go and like copy and paste them into the land vehicle class. They're there automatically. All right, so let's go look at the code. All right, land vehicle is going to look like this. So land vehicle has a number of wheels field, right? So we want to keep track of the number of wheels that this vehicle has. So again, they could know how many tires to order and that kind of stuff, all right? So I have this number of wheels. If you look though, what's going on is that the land vehicle class will automatically inherit this vehicle ID number and this manufacturer field from vehicle. So even though it only looks like there's two fields, land vehicle actually has three fields. Okay, it has a vehicle ID number, it has a manufacturer, it has a number of wheels field in there. Okay. Okay. Inside here I have a toString method. Okay. And so in the toString method, you might notice that the parent class has a toString method as well. Okay. And so this is an example of what's called an overridden method, which we will talk about, right? The parent has this toString method. It is automatically, the child class automatically inherits it. But the child class is also free to redefine the toString method. And so over here, yeah, the parent toString is okay. It mentions the vehicle type and the manufacturer. But with the land vehicle, we also want to tack on an additional piece of information about how many wheels it has. Okay, so in addition, right, to inheriting, it also inherits the get and set methods, right, for all of the fields, vehicle ID number, and manufacturer. Okay, so the child class also inherits all of these methods inside of here. All right. Then I have a get and set method for the number of wheels field. Okay. So you can see inside here the toString, I'm using the get manufacturer method, but if you look through land vehicle, there is no get manufacturer method in there because it is not necessary to put it in there because it is inherited from the parent. So it will use the parent's get manufacturer method. Okay. So here, when you call this get manufacturer method, Java will look and say, oh, I don't see any get manufacturer method here, but it will check this and go, okay, well, it's vehicle, so the get manufacturer class is in vehicle. So it will go there and it will see, aha, here's the get manufacturer method. All right. All right. So now, one thing, and let's go ahead and run this land vehicle class here, and so you can see how that goes. Here I create a land vehicle object, and I set the vehicle ID number, I set the manufacturer, and I set the number of wheels, and then I print it out. All right, and so when we run this, we're going to see that message, land vehicle, whatever, has 2 wheels and was manufactured by Ducati Motor Holding SPA. So we can see that's this message right here. That is the toString method, right, that's getting called. All right. Okay. So now, going back to land vehicle, there's something that I want to point out here. So if you're paying attention, you might say, well, you know, why do you have number of wheels here? If you look at it, right, that is just referring to this variable here. But if you look at vehicle ID number and you look at get manufacturer, I'm using the get methods from the parent. Okay. So what is the difference between there? So the issue why I'm doing that, right, is because if I look in vehicle right here, these fields, vehicle ID number and manufacturer, are marked as private. See, that's marked as private. This is marked as private. And if you remember back to the first part of Java, if it's marked as private, no outside class can use those fields, can access those fields. They would have to do it through the get and set methods. And in fact, that includes any child class as well, right? So this child class, you might say, hey, I'm just going to change this to vehicle ID number. Make sure that matches this exactly. Nope, it doesn't. So instead of using the get method, right, this is a child class. You told me it inherits all of the fields and methods from the parent, so I should just be able to put vehicle ID number in there and it should work fine. All right. When I do that, you see now I get an error. It says vehicle ID number has private access in vehicle. Okay. So because the parent has marked this field as being private, okay, then that means that no outside class, even a child class, they can't use it. Okay, it's there, but the child can't use it. So that's a little bit irritating to have that happen. Okay, so if you want a child class to have access to that, then what you will need to do is in the parent, instead of marking it as private, you will need to mark the field as protected. Okay, so private means no outside class can use it, not even children classes. Okay? When you mark it as protected, it means no outside class can use it except children can. All right? So this allows the children class, the child class, to use this. And so now I'm going to compile vehicle. It's protected. And when I go back and compile land vehicle, you will see no more errors. So now this becomes okay. So if you have some fields in the parent class and you want the child class to be able to refer to them without using the get methods, then instead of marking it as private, you would mark it as protected. If you were in my Java 1 class, you might say, hey, you might have heard me say, you should always mark these fields as private unless you have a good reason not to. And in Java 1, I said, there's not a good reason to do that, okay? And but now in Java 2, there is a good reason, right? And that good reason is if you want a child class, right, to access the field without having to use the get methods, okay? So it's either private or protected for these fields in our class, okay? Okay. So let's just do the same thing. Let's go to land vehicle, and instead of using the get method to get the value of the manufacturer field, I'm going to go through and just change this to manufacturer, and you're going to see that's going to cause an error because manufacturer is marked as private in the parent class. If you get that message, right, go over here and change it to protected if you want. Compile the parent class back. Right, and then when you compile the child class, you'll see that it works. You don't have to do that, right? You can continue to force the child classes to access through the get methods, but it's just a little bit easier this way, in my opinion. All right, so that is the protected access modifier, okay? In the protected access modifier, then, like I said, it allows child class to access a field in the parent without any outside classes doing that. Okay. All right. Like I mentioned about the toString, when a child class modifies its parent, a method in the parent class, a non-static method, it's called method overriding. Okay. For method overriding, one thing I highly encourage is to mark those overridden methods with the @override tag. Okay, that forces the compiler to double check that the method is actually overridden. Okay, so let's say in our land vehicle class, we know that right now when we run it, it looks like this. It prints this message: land vehicle has 2 wheels and was manufactured by Ducati Motor Holding SPA. All right. So if I go back over here to land vehicle, and I just slightly mess with the toString method. The toString method is the method that's being overridden. And a common mistake is forgetting to capitalize that capital S. So if I change that to a lowercase s, you're going to see everything compiles fine with land vehicle. When I go run land vehicle demo again, you can see now, right, that message about the wheels is missing, right? Land vehicle, whatever, has 2 wheels. Just by changing this this uppercase s to a lowercase s, okay, you can see that the message about the wheels is now gone. So the question is, what happened there, right? So right here, when I went to print this out, okay, system.out.println LV1, Java went over and checked the land vehicle class to find a class called toString with a capital S. It saw this one and said, no, that's not right because that's a lowercase s. It should be uppercase s. So the next thing it did is went to the vehicle class and checked to see if it had a toString with a capital S in there. And sure enough, there was. So it's using the parent's toString method. All right. So you can see that wasn't much of a change, and it was kind of hard to notice. If you had accidentally just changed this to a lowercase s and weren't paying attention and just said, okay, yeah, it's running fine, and didn't really look at what it printed out, you would have totally like missed that error. And who knows, a couple of weeks later, when you're working on more of your application, maybe, you know, maybe it causes some error, and then you're kind of stuck going back through everything to try and figure out, you know, what went wrong. Okay, that's not a good situation. That's an example of a logic error, right? Which is the most complicated type of error to track down. It's easy to make, right? In this case, just one letter off. I got no warning at all, right? So, and it could be very, very hard to track down. All right. So, in order to prevent that from happening, what I highly recommend is if you override a method, right, that is, you think, okay, I am going to use the, I am going to change an inherited method, right, then what you should do is mark that method with the @override tag. The @override tag, right, will now double check to make sure that this method is actually overridden. So just watch the effect of the @override tag. If I try to compile, right, but remember before it compiled just fine, okay, but now it does not. It says, in fact, you can just see if I have this @override tag without it, comment it out, compiles just fine. With it in there, it does not compile. Okay. So, so it says method does not override or implement a method from a supertype. When you add this @override tag, you are basically telling Java, say, hey, Java, just check me out here and make sure. What I want for you to do is go back and check in the parent class, right, and see if there is a method with exactly the same method header in there that I'm actually overriding it. And if you don't find one in there, go to its parent and see if you can find one. And if you don't find one in there, go back to its parent, right, and so on and so forth. So Java, when I put this @override tag, is now checking to see, and it finds, hey, I've looked back through all of the parents and all of the parents' ancestors, and I cannot find any method that has this exact method header in there. So now that goes from being a logic error to being a syntax error, which are really easy to track down. If you get this, you know, when you're overriding, method does not override or implement a method from a supertype, then you would go back and check, is this exactly what it's supposed to be? And then I could see, aha, I typed a lowercase s instead of an uppercase, all right, and you can see now it will fix that issue, okay? And then when I go back to land vehicle and run it again, you can see now the message about the wheels is back, all right? So it was using this toString, right? When it was messed up, it was using the parent's toString right here. And if you do it in both places, well, I can't really do it now, but let me just show you. If you do it, mess it up in both places, you'll get the toString of the object class. All right, if I go back here and recompile and print that out, now that is the toString, which obviously, right, that's not what you intended there. So to check that again, when you're overriding a method, you should put the @override tag on there just to double check yourself. And now when you put the @override tag there, right, you'll get a syntax error. Same thing here. All right, so the @override tag just helps you to catch those kinds of errors. I think I forgot to change it back to an uppercase S. All right, so that is the @override tag. Okay, so there are some occasions when you have an overridden method and you want to use the parent class's version of the overridden method for whatever reason. And in the when we do some examples here, I will show you how to do that. And so, and I'll show you here, but it's not going to make a whole lot of sense in this context, but as to why we would want to use it. So when you have an overridden method, just like the toString method that we are talking about here, right? That means that you have a method in your child class that has exactly the same method header as in your parent class right here. Right? See how those are exactly the same. So the parent has a version, or some ancestor of the parent has a version, and the child class has a version. So there are some times where you would just want to use the parent version over the child. Maybe you don't want to redo everything completely. Maybe in this message it's a totally separate message, but say you want to just you want to build on what the parent method does. So just to show you how this works, right, I am going to just put a print statement on here. So you would normally never do this. So I'm just going to show you how this goes. So whenever you see super, right, the super reference, it's kind of like the this reference, right? How the this reference points to this class. The super reference always points to the parent class, right? So this is basically telling Java, hey, go to the parent class and give me the result of the toString method, okay? And print that out, all right? So I'm going to compile that, and then when I run the land vehicle demo, then you are going to see two methods, or two messages. And you can see this was the result of this line right here, super.toString. That called this toString method in the parent, when that just prints out the vehicle ID and the manufacturer. Okay. So maybe you want this message to be displayed instead of this one for whatever reason. You can do that, okay, with overridden methods. There are some types of methods that you do not want to override. Those are static methods. Those are shared by the class anyway, right? Remember, static means they're shared. So there's no need to do that. Okay, and final methods can't be overridden. Right. So if you mark a method as final, then you can't override that method. That prevents people from using your code in ways that you don't want. So it's kind of like a safety check in there. Also, if you marked your class as final, then methods in those final class can't be overridden. If a class is declared as final, it cannot be a parent class. And I can just show you a quick demo of that. If I go here and mark this class as final, all right, you can see vehicle compiles just fine, but the child class, I'm going to get an error when I compile that. Right? And it says cannot inherit from final vehicle. So if you mark a class as final, it can't be a parent anymore. And you can do that to prevent people from changing your class. I've seen some people argue when development in teams, when one team has some code that another team wants to use, and they'll be like, hey, can you your class is marked as final, can you make that so I can inherit what you did, but change it, and the first coder say no, I'm not going to do that, and then they got into a huge argument about that situation. So but we won't worry too much about that, but you can prevent things from being overridden. If you feel like the future people are going to take that and do things that you do not want done, that might break your code, then you can mark it as final. Finally, overriding does not work for fields. Okay. So if you try to override a field, then it's not going to work in the way that you think it's going to work. You basically get two different versions. That can be pretty darn confusing, right? So what you do not want to do not create a field with exactly the same name as a field in the parent class, in the child. The fields, don't do that. You already get that for free, so there's no reason to do that. All right. With methods, you can, certain methods, that's fine. Don't do it with fields. Okay. All right. So that's about it for this one. Before we start getting into examples, then or writing our own examples, then what we will do is we need to talk about constructors, because that's a separate issue. And that's what we'll do in the next video.